Hello, and welcome to another episode of JavaScript Jabber. We have the panelists today, myself, Amy Knight, and along with me, we have Steve Edwards.
Hi, from cold and rainy Portland.
AJ O'Neill.
Yo, coming at you live from the deep inversion of Pleasant Grove, Utah.
And Dan Shapiro.
Coming to you from warmish Tel Aviv, where it's supposed to start raining tonight, so we'll have a little bit of a winter.
Okay. And since it is us, and we've done the first two installments of things that every JavaScript developer must know, we're going to do installment 3. Looks like we have about 6 things up for debate, and we're going to get started with duck typing. I think AJ really wanted to talk about this.
This episode is brought to you by Dexecure, a company that helps developers make websites load faster automatically. With Dexecure, you no longer need to constantly chase new compression techniques. Let them do the work for you and focus on what you love doing, building products and features. Not only is Dexecure easy to integrate, it makes your website 40% faster, increases website traffic, and better yet, your website running faster than your competitors. Visit Dexecure.com/JSJabber to learn more about how their products work.
Let's start off by probably explaining what is duck typing and why do we need to know what this is specifically for JavaScript.
Duck typing, if it looks like a duck and it quacks like a duck, then it's a duck. So, and when you don't have classes, or even if you do, like Golang has not classes, but structs, and it still uses duck typing. But it's when you detect something based on a feature of an object. So say, for example, if an object has a particular property like a name and an age, then it doesn't matter specifically whether it's an animal or a person, if you have some sort of function that only needs to care about name and age. So it's kind of a way of avoiding heavy type systems when the only thing that's relevant about an object is the property that you need. Like the inheritance of it doesn't matter. You know, if you're just adding together, and I can only think of bad examples or like contrived high school type examples.
I have an example.
Oh, go ahead.
The example that I have, I actually consider it kind of the canonical example, is Venables. The concept that in JavaScript, if you want to be considered to be kind of like a promise, all you really need to do is implement a then method. That's enough for most cases. And indeed, in JavaScript, you have the concept of a thenable, which is literally any object that has a then property, and that property is a function or method. And if you are thenable, then most of the promise constructs work for you. You can pass such an object to promise all or promise race and various other things that expect promises, and which makes it really easy for you to implement this sort of a functionality if you want to use your own for some reason instead of the standard one. And it really ties to the fact that in JavaScript, really objects are just essentially property bags, dictionaries where the key is just a string, or as we previously learned, symbol, and the value can be really anything. And then if you have the appropriate properties in your bag, then you're good to go. That's kind of the concept of duck typing. Like AJ said, it's kind of common in scenarios where you have more dynamic type systems, let's call them, where you don't have interfaces. In language that have interfaces, they state the functionality that they have by implementing a certain interface. That's kind of what Java does. If you want to be treated like an iterator, you probably need to implement an iIterator interface or something like that. In JavaScript, you just implement a next method, and then you're treated as an iterator. So that's another example of where just having the appropriate property or properties is all you really need to be considered as something. And
I think, I just wanted to add in your explanation there, I think you answered right then and there, like why that's important in JavaScript because of the dynamic nature.
Exactly. And like AJ said initially, it doesn't really matter so much how you got that property, whether it was directly added on your object, whether you got it via your prototype, or if you're using classes, whether you got it via a class or a class that you're extending, which are just essentially syntactic sugars for prototypes. But the reality is it doesn't really matter how you got that property. As long as you have it, you're good to go. And really, it's kind of essential, I guess, because it's how JavaScript operates. If you don't understand the concept of duck typing, then you lack basic understanding of how JavaScript works, about the intrinsic logic of the JavaScript madness, I guess.
And I think that interfaces and duck typing go hand in hand. And JavaScript doesn't natively have interfaces per se, as far as I'm aware, but they are common in Golang and TypeScript and Rust. Like most of the modernish languages have interfaces that are duck type interfaces.
Yeah, also, obviously, TypeScript has to accommodate it since it's just such a common pattern in JavaScript, and TypeScript needs to accommodate essentially as many JavaScript patterns as it can. So it does have the concept of specifying that something that is being passed implements a certain or has a certain property, and then the TypeScript type checker can actually do at least some of this duck type checking at compile time to verify that what you're passing indeed looks like a duck, and you're not trying to pass in a cat or something like that. But yes, usually it's more common in dynamically typed languages than in statically typed languages.
To clear up possible confusion, which maybe nobody's even confused this way, but duck typing is absolutely not when you have something like it's the letter 2, so we can use it as the number 2. That would be implicit coercion.
Oh, for sure. And you also need to be kind of careful with duck typing, because it can get you into trouble. Because if you use the same property, let's say name, to indicate different types of functionality in different types or objects or whatever, then you can get into trouble if you then pass something to something and it expects a certain behavior but then gets something else. Like, again, in a sort of a canonical example is I have a draw method, but am I supposed to be drawing a picture or drawing a gun? And it's not the same thing, but they both happen to be the same word. And if I assume based on duck typing that they're both the same, I can shoot myself in the foot when I just wanted to paint my toenails or something.
And to be more, I think a better example of this would be something like you want to know whether an object was the object that you intended to get, or if it was an error message, like back from an HTTP request. You might do a little bit of duck typing. You might check like if message, then, or if object.message or response.body.message, then this is an error. But then there may be a case where you actually have a result object that is not an error that also has the property message. And so that's, I think, a very common example of where you could get yourself in trouble, where you're looking at a property on something to determine, is this the result object, or is this the error object, or is this the warning object, or whatever, and you happen to overload something that has, they both have that property you were checking for, and you have to go back and update your check.
Well, I think we can summarize that JavaScript developers need to understand the concept of duck typing. If maybe they're not familiar with the term, if they weren't, well, they are now. And it is something that JavaScript developers should be familiar with, because it's inherent to how JavaScript operates.
So with that, should we go out of turn and go to TypeScript and talk a little bit about that one? Okay.
Yeah, I think so. Let's go on to that, because that was a good place to end there. So I personally do not think that you need to know about TypeScript to be a JavaScript developer. I think you should know what it is. I don't think you need to know it. I am curious, though, others' opinions here.
Define JavaScript.
Well, it's an implementation of the ECMAScript specification. That's the definition.
It seems to be whatever a large number of people transpile in a browser. So I would say that TypeScript is something that if you're going to be a JavaScript developer, quote unquote JavaScript developer, if you're going to be a web developer, I think that you need to learn some TypeScript because it is so pervasive right now. It's highly unlikely that you're going to be a JavaScript developer. You're going to be a web developer, and you may encounter JavaScript along the way, but it's more likely that you're going to encounter these ECMAScript compiled languages, TypeScript compiled languages, JSX compiled languages. And so I think TypeScript is so pervasive that much like JSX, you don't need to learn JSX if you're actually just writing in JavaScript, but who writes in JavaScript anymore? So I think TypeScript's important in that regard.
I would phrase it in this way. I think you can be a JavaScript developer or web developer without knowing TypeScript. It's not mandatory knowledge that you absolutely have to know in order to create web pages and to use JavaScript and build web applications. But
Okay.
like you hinted, AJ, it's becoming really prevalent out there. It's becoming pervasive, and it's going to be. Let's put it this way: there's a good chance that when you interview to get a certain job, that they may expect that you know TypeScript because they've decided to use TypeScript.
The thing that scares me is I think there are a lot of people who they say they know TypeScript, but when push comes to shove, it just becomes a sea of any. And it's almost like a recursive statement. Like, to know TypeScript, you need to know TypeScript. Like, you can't. To me, it's like you need to know more than just like 10, 20% to actually successfully use it in your project. Like, I know they sell it as like you can just, turn everything to a TypeScript file and you're good to go, which is true, but you don't really get the benefits if you're doing that. And to me, it's not worth it at that point.
So, Amy, what are the benefits of TypeScript?
I mean, the place where I worked, where they really, really, really tried to shove it down our throats, it was because we didn't have any tests, and they thought that being able to add types to everything, we'd be able to, infer what different methods we're expecting and stuff like that, which is true in theory, but I know people that work at this place now, and it is exactly what I was afraid of, and many people were afraid of, is it's mostly a sea of any's. There's probably like 10% of the code base that has types. And I mean, again, to me, yes, it's definitely valuable, but there are so many other things that unless the team is really like all in and has the time to devote to it, I really think it just becomes like clutter and noise.
I would say that transforming a JavaScript code base into strict TypeScript is so much harder than writing tests. So thank you. If the point is that we're missing tests, well, then go out and write tests. TypeScript, first of all, is not a substitution for tests, and the second thing is like you experienced. Actually transforming your code base into strict TypeScript is really difficult. In a lot, if your JavaScript code is really simple and straightforward, then, maybe it isn't that bad. But there are a lot of from my experience, there are a lot of JavaScript common practices that are really difficult to codify in TypeScript. The TypeScript doesn't really lend itself to that well. If we were talking about JavaScript objects as property bags, where you can literally just add and remove properties from a JavaScript object, TypeScript really wants your object to have a specific shape. It doesn't like you adding and removing stuff from objects in this way. And if your code does it, then things can get difficult. Now, they've done an amazing work in JavaScript and, with generics and infer types and whatnot, but it's still potentially quite challenging. By the way, at Wix, we are really moving towards TypeScript in a big way. A lot of it has to do simply with the fact that these are really large projects, even huge projects that have tens, sometimes even hundreds of front-end developers working on them together. Very often, you've got different teams working on different parts and having clear and interfaces that where the types are codified within the interface is kind of a requirement to avoid situations where the wrong types of unexpected values are passed between various modules and stuff like that. But it isn't easy. And by the way, we are actually enforcing strict TypeScript. So it's possible to use any, but you kind of, it needs to be sort of an escape valve. You really need to put a comment there that, like a flag that says, I'm going to be using any here. And you might even get a warning. So yeah.
Where would you use any when you actually need a hash map?
Yeah. Again, I don't have a good example off the top of my head, but I can tell you that the code really doesn't have that many any's. But another important point, which is related to what Amy said before, was the fact that we didn't take existing JavaScript code and then transform it into TypeScript. This was literally done as part of a rewrite. So the code was effectively rewritten in TypeScript. It wasn't just converted to TypeScript or.
So I want to throw on top of this. I think my opinion is you should learn JavaScript, try to learn real JavaScript decently well. And before you learn TypeScript, learn a modern typed language, something like Golang or Rust or what's the other one, like Crystal. There's a bunch of ones out there, but learn a modern type language, because TypeScript is kind of like, let's take 1990s Java and apply it to JavaScript. And when I look at it, to me, it's very ugly, because it's like, wow, thank you, C++ sharp Java. What are you doing here?
I have to agree with you. I think that TypeScript people have done an amazing job of retrofitting a type system over the poster child for dynamic typing, which is JavaScript. JavaScript is like almost the most dynamically typed programming language out there. So being able to put a type system on top of that is like, I don't know, corralling really wild horses. But you're absolutely correct that if you start with a language that was intentionally designed with a type system in mind, you're going to have a much clearer understanding of what all this thing is about. But again, going back to my original point, I think the reality is that we're getting to a point where if you're a JavaScript developer that has no knowledge of TypeScript, you might be limiting your job market.
Agreed, as much as it pains me. So, other important programming concepts people should know?
Let's see. So we have recursion, garbage collection, MVC, and then I'm sure we have others.
Oh, there's a million of them.
Why recursion? I would answer, but I don't know, since I'm posting.
So if you don't get recursion, again, this is one of those terrible statements that I'm going to make, shoot me, hang me. You're not a programmer. You're a code monkey. It's important. If you don't, because it's so fundamental to logic and just everyday life logic. I mean, once you know how to name it, because it's just something that if you're not thinking in terms of recursion ever in any aspect of your life, you just don't use logic in your life. Being able to say that where something ends is where it begins, and that's like a terrible way to say it, but being able to understand how to go down a layer and repeat a process and go down a layer and repeat a process until an end condition is just important to logical thinking, period. And it may have a weird name, but it's not, I think it's difficult to explain, but easy to understand.
Yeah, and I'll just like say too, I think it's important and it does deserve to be on the list for like newer people listening. I don't think you should like beat yourself up if you don't get it within a day. If you're new to programming, it's a concept that takes a little bit to get used to, but it is important. Just because it's hard doesn't mean you should ignore it.
Sorry, go.
I was just going to say, I don't think it's hard. I think that it's a difficult name. I think.
It's harder than like, function add 2 + 2. If you're not used to it, it might take a day or two to, understand what's going on.
Sure. Like learning the terminology, naming it and understanding it, like learning the what's the canonical problem is the Fibonacci sequence, right? Or do we have another one that's like a good canonical educational?
Doing something over a file system is usually, I think, the best example.
Yes, a tree. That's perfect. Yeah, if you want to implement the program tree or a recursive LS, recursive. There we go. Descending. Yeah,
I totally agree with everything you said, AJ, and also what you said, Amy. I think that it separates, without sounding misogynistic, the men from the boys. Or the women from the girls, or whatever, the people who actually get it versus people who just bang away at it. By the way, an amusing point here. There's a legend that originally Scheme was supposed to be the language in the browsers, rather than something, that Brendan Eich created, which is JavaScript. I think Brendan Eich has actually denied it, but I think there was a certain point in time where they were considering it. And the amusing thing is that in Scheme, recursion is the only way to do loops. If you want to do a loop, it has to be recursion. So yeah, those of you who don't get recursion, be happy that you're using JavaScript and not Scheme.
But also, I think it's totally possible to learn. I wish I had a good resource I could link people to, because I think it's not like monads. Like monads is one of those concepts where like apparently everybody uses it, but nobody understands it or knows how to explain it. That would be my canonical example of a computer science concept that is really, really hard to understand. I don't think recursion is hard to understand. I don't want to scare people.
No, it's like
you apply your brain.
Yeah, for me, I think it was like one of the first things where I understood like why you have to be good at abstract thinking, because it's more of like an abstract concept, I feel like. At least to visualize it.
Yeah, at least to name it, because it's something that you would naturally do. If you were walking in a maze, you would recursively check each path. If you were methodically walking a maze as a human in a corn maze or in a, whatever. So yeah, it's something that you naturally do, but abstracting it to understand it is the hard part.
And I think it's important too to know about it in JavaScript, because of the nature of JavaScript not being fully functional, but also being object oriented, and recursion being more of like a functional concept.
So now that I'm using more async await, I'm actually using less recursion, and I don't feel bad about it.
Okay. How about garbage collection? Why is that important to know in JavaScript? Is it important to, I feel like you need to know what it is. However, because that's abstracted away for us, how much do we need to know?
If you don't collect the garbage, your code gets stinky. It just goes without saying. Right?
It's only important if you want to save $250,000 on your Amazon bill. If that's not important to you, you don't need to know it.
Please elaborate.
Well, I was meant that as a side joke and someone else to go back to their more serious topic. But so garbage collection is what uses RAM. So it's that in JavaScript, there actually are ways that you can mark something for the garbage collector, like assigning null to it.
Oh, I think that you're diving into the deep end before.
Well, no. Hold on. I was just going to say that you in many languages you manually manage memory, meaning you tell the program when you're done with something, and assigning null is a way to tell it that you're done with it in JavaScript. But in other languages, there's like free keywords or delete keywords. So when you are done using a variable, you tell it, I'm done with this thing. And in JavaScript, what it does instead is if it's returned from the function, if it's not returned from the function, then it probably will just get garbage collected right away, because this is an optimization modern things use, is if it doesn't go outside the function scope, it just knows to get rid of it. But if it's returned from a function and it starts to be used in some place in the program, it goes into what's called the heap, which is just like it sounds. It's just a big blah of stuff. And when it's no longer being used, occasionally JavaScript stops running code and walks through the heap and keeps track of each of its internal references to that thing. So you have a name for your object, like you might call your object person. But internally, each object, JavaScript has its own name for that thing that is a memory address, essentially. And so when you assign one thing to a person, and then you're looking like, is it person A or person B? And you decide that it's person B that you need to assign to the person variable. Well, now person A is not being used anymore. And at some point, JavaScript will walk through all of the memory references and check to see if any memory reference is located anywhere else in the memory stack. And if it is, then it keeps it. And if it isn't, then it says, oh, okay, there are no longer any references to what you used to call person A and what you've now replaced with person B as the person variable. There's no more references to that. So I'm going to free it up and I'm going to release that 2 kilobytes of memory back to the system. So did I go too deep? What would you?
No. I think that's actually. I think that's actually a good explanation. It certainly, at the base level explains what it is. Look, I think in an ideal world, JavaScript developers, or actually the developers in many modern languages, because garbage collection has become a sort of the de facto standard for most programming languages these days. It exists in Java, in C#, in JavaScript, in Python, etc. And if you've only programmed ever in programming languages that have it, then you might not even have a name for it or think about it too much, because it's kind of like the air we breathe. You don't think about the air. I happen to have arrived at JavaScript from programming languages that, like you said, require a manual management of memory, languages like C and C++, where you really need to be explicit about allocation and deallocation of memory resources. So ideally, I would have, I might have said that you don't need to think about it because it's just something that's always there. But the reality, I think, is that you actually do, because it is still possible in JavaScript to leak memory. And if you have no concept of the garbage collector, then you won't have any concept of what a memory leak is. And especially if you're writing stuff for the server side, but even for the client side, if you're writing for Node, it's so easy to get your server to crash if you're leaking memory. And like I said, if you don't have an understanding of the concept of garbage collection, then you won't understand maybe even the concept of what is a memory leak.
I agree with what y'all are saying.
And to go back to the $250,000 example, because I didn't actually clarify that, and I'll link to this in the show notes. What is it? Plaid here in Utah. They started moving their offices here, I guess, because it's cheaper than San Francisco or whatever. But they one of their engineers gave a talk in which he saved the company $250,000 by basically doing 2 or 3 small things. One of which was just adjusting the node garbage collector heap size. So, and if you ever run create React app build processes on a VPS, you'll run into this problem where it just like fails and the error message is nondescript and you don't know what's going on. And that's because if you use too much memory, your program crashes. And you typically don't need to have all of the memory that when a program crashes, the problem is usually poor memory management, not that your program needs that much memory. And so you can have things like Swap space is on the operating system side, and garbage collection is on the virtual machine of the language side. But if you don't do a couple of simple things with your to make sure the garbage collection is happening and make sure that your heap size is reflective of your program, then you have to purchase huge amounts of RAM on cloud services where RAM is extremely expensive, where very small amounts of RAM may have done. And then you may also run into problems where, like, if you put 16 gigs of RAM into an instance on AWS or DigitalOcean or whatever, and you run your node program, but your node program is capped at a 4 gigabyte heap size, then your program will run out of memory when you get to 4 gigabytes, which most likely is because you have a memory leak. But in some cases, you actually have enough connections and enough things in flight that you do need more than 4 gigs of RAM. And so you need to know that this memory space exists when you're dealing with either problems that are scaling to larger, like there's an unbounded number of clients or connections that you might service on your in a single instance of your service, or where you're not being I guess where it becomes a problem is where people are not cognizant of being somewhat conservative in what they're doing. And say you read an entire file into memory and it's 100 megabyte file instead of streaming it, for example. If you take up this memory, then your library will affect other people, and then they'll have problems where their program is crashing. I don't know if I said that very well, but the idea is that there are small and simple things that you can do that can make orders of magnitude difference in the order of 100 or 1,000 or 10,000 times improvement in memory management. And it can save you, if you're at any place where you're scaling an application, that knowledge can save the company hundreds of thousands of dollars, can save developers time, and can make you valuable. But again, you're not always going to end up in that situation.
I totally agree. I would just add that you can delve deeper with garbage collectors, because how they actually operate, it turns out is they're really sophisticated. JavaScript usually has a 2-generational garbage collector, which means that it kind of makes a distinction between long-living objects and short-lived objects. But for that is, you don't really need to know. It's interesting. I think it helps you become a more seasoned developer, maybe even write more efficient code, but it's not like mandatory knowledge.
Okay.
The takeaway would be use streams. For the average person, use streams. Don't read files into memory. And if you're having performance problems where memory's spiking, learn more about it.
And there you go. That's good. How about MVC?
I think that's kind of related to a topic that's further down on our list, which is frameworks. Because usually you think about MVC in the context of frameworks. Okay,
let's push on then to the number system in JavaScript. I definitely think this is very important.
Why?
That's the bulk of what you do in, maybe I'll backtrack there. Depends on the application you're working on. But, as like a new programmer, I think a lot of times, especially in JavaScript, people like to poke fun at some of, the things that occur with numbers in JavaScript, but it's the same for a lot of programming languages. But it's also important to understand, let's see what we have on here, like precision, what the not a number type is, BigInt, which is newer. All of these things I feel like you will come across sooner rather than later in your career.
So I feel like NaN is the most important of the things that you mentioned. It's you're most likely to wreck your head against it. And why is that, Amy?
Have you ever wondered if you could be offering a faster, less buggy experience for your customers? Let's face it, the only way you're going to know that is by actually running it on production. So go figure it out, right? You run it on production, but you need something plugged in so that you can find out where those issues are, where it's slowing down, where it's having bugs. You need something like that there. And Raygun is awesome at this. They just added the performance monitoring, which is really slick, and it works like a breeze. I love it. I love it. It's like you get the ray gun and you zap the bugs. Anyway, definitely go check it out. It's going to save you a ton of time, a ton of money, a ton of sanity. I mean, let's face it, grepping through logs is no fun. And having people not able to tell you that it's too slow because they got sidetracked into Twitter is also not fun. So go check out Raygun. They are definitely going to help you out. There are thousands of customer-centric, customer-focused software companies who use Raygun every day to deliver great experiences for their customers. And if you go to Raygun and you use our link, you can get a 14-day free trial. So you can go check that out at javascriptjabber.com/Raygun.
I mean, I don't know why. I've definitely like hit it before, especially like front-end programming. A lot of times, like your inputs, I think like when I was super beginner, I can remember hitting this because the inputs are usually strings, and a lot of times you'll get nan as a result. Or that's like a popular bug that people like to take screenshots of in different applications.
Math man.
Yeah, I think it is worth mentioning, like you basically said, that it's not really necessarily specific to JavaScript. I mean, people often talk about when people poke fun at JavaScript, usually it revolves around three things from my experience. One is the implicit type conversions, which a lot of people just don't understand, or they like to show weird examples that don't really happen in real life. Another example is the behavior of this, which we actually discussed in a previous episode. And the third one is the number system. But the point that they miss is, like you said, it's the number system in JavaScript is not really specific to JavaScript. It's IEEE 754, and it's actually common in a lot of programming languages, and they all suffer many of the same limitations, like how much is 0.1 plus 0.2? Well, guess what? It's not exactly 0.3 because of how floating point in computers works, and these sort of things. And I definitely agree that the concept of nan is confusing. I think part of it is slightly JavaScript fault. The fact that if you do a type of nan, the result is number, which means that not the type of not a number is a number. I think some people find that confusing, although when you think about it, it kind of makes sense. But initially it looks weird.
That's all programming languages. Infinity is a number. Nan is a number. I mean, nan is equivalent to, well, not equivalent, but is also used as the mathematical undefined, as opposed to the JavaScript undefined, which is not related to the mathematical undefined. But nan can be used in the places of mathematical undefined as well. But not a number for those that are listening. Not a number just means like if you multiply the number 3 by a function or an object or the word dog, you might get back nan. And if you add the string 3 with the number 3, you might get back 6 or you might get back 33. So it's just a lot of times nan is part of the implicit type coercion, and it's typically where it tends to go wrong. And it's why you might see a check of like parse int something something or 0, because it's possible that 0 comes out of parse int for a bad numerical value, but it's also possible that nan comes back. Like if you do a parse int on the word bear, it may come back as nan, and so you'll see people do like parse int or 0, so that they're guaranteed to get a number even if the result is accidentally nan or false or something else like that.
The thing is, in some other programming languages, instead of having the concept of nan as not a number that can be the result of certain computations that are effectively invalid, they just throw an exception.
And I think that is beautiful.
Is that really beautiful? Would you prefer that JavaScript would throw an exception whenever a nan would have come out?
Absolutely. Like why? Like, because there's no reason if you're except it's like Amy said. Not to say that experts don't have the same problem, but it's a rookie mistake to get your string inputs and put them into a calculation. It's not to say that it's not common and that like I don't do it on a regular basis, because I do. Like I make that mistake and I'm like, oh yeah, I forgot to convert to a string. But how much quicker do you find that mistake if it would just throw rather than like 6 functions later? you get a nan, and then some intermittent function you got 33 where you should have gotten 6. You know,
I kind of like that idea. Although that's like the core of JavaScript to do coercion.
Yeah. Well, there are two things here. First of all, you need to remember that when JavaScript was created, exception handling wasn't there yet. So initially, JavaScript, didn't have try, catch, and throw. So they needed to do something. So that's just and then we're stuck with it because you have to maintain backward compatibility. So that's one point.
But strict mode should have fixed it.
Maybe. The other thing is that from my experience, so many developers don't use exception handling properly. And that if JavaScript would have thrown exceptions in all these scenarios, then a lot of developers would literally wrap each and every computation in a try-catch and have it return 0 or something stupid and weird like that.
Have you seen anybody else's async await code?
Well, okay, exactly.
That's what everybody's doing anyway. I mean, it's bad.
Well, that's because maybe we should have had try-catch here on the list, because I think that the unfortunate truth is that most developers, and JavaScript developers and other programming languages as well, don't really get exception handling.
I agree with that. We should have had that for sure.
Well, let's talk about that.
Let's do it now. That is one of the number one things I see people missing in async await is not having the try catch around it.
But again,
or having too many layers.
Async await is just a more complicated example, but I've seen so many examples of code that's totally synchronous that doesn't use exception handling properly, where people use some function that throws an exception, but then immediately wrap. I remember seeing a code, actually it wasn't even in JavaScript, I think. I'm trying to remember if it was in Java or C++, where they would literally wrap everything that might throw in a try-catch so that they could return null or something like that. So many developers just are afraid of exceptions, don't get exceptions, don't really understand where exceptions go and how they're supposed to be handled across functions and so forth.
I feel like that's just a lazy, not thinking. It's because what do you do when things don't go perfectly? To me, and I think I'm going to say this is one of the things that I caught early on in my first computer science class in college. I developed this pattern, and it has helped me throughout my career. And it's one of the things that I think is not I don't necessarily write clean code. I write sloppy code just like everybody else, but it's one of the things that helps me write cleaner code than I would have otherwise. And that is that you think about the last thing first, the last shall be first. And you think about the what if it goes wrong. You look for the exit condition. So you start your code on line 1 of your function. What if I need to bail? And you try to handle that situation first, so that instead of having nested try catch, or just having your whole program crash, you say, okay, well, what could go wrong here and how important is it? Because something you don't want to handle every possible case. Was a string input? Well, I only accept numbers. Well, is the number greater than 5 million? Well, that's an unrealistic number. And what if the number is less than, you might not want to handle, go to an extreme, because then you'll end up with 50, error checks, and you're basically replacing type checking and other systems that are appropriate for that type of thing. But when you start your function with what are the exit conditions, or what are the error conditions that I should be returning null, or I should be throwing an error, and try to handle it that way, rather than thinking, okay, what if everything's perfect, and then getting to line 27 and being like, oh, okay, well, if it's not perfect here, then it'll just crash, or it'll just throw an error. Try to get that stuff up at the top, not down at the bottom.
It's funny, but for me, I use exception handling so that I can actually do kind of the inverse of what you just described. When you do error handling as return values, then your code needs to be full of checks for return values that indicate problems. Whereas if you work with exceptions, you can write your code as if it's just the happy path. Just don't think about the errors at all. Throw things, throwing, you can't put it in there. If you got invalid value, just throw, but don't think about the catches at all. And then put the catch just where you have sufficient context to do something with it. Because I think that's the problem that a lot of people that don't get exception handling, that's the mistake that they make, that they catch errors where they don't have enough context of what to do with them. So they catch them, and then they either just console log it and wash their hands of it, or they rethrow it, which is kind of like passing the buck. So why did you catch it to begin with? So do the throws, but wait with the catches till the very end.
And I don't disagree with what you said, and I think there certainly are, like, for example, if you're writing a parser. And there's a lot of misconception about this, the way that programming languages handle this, because some people think that doing try catches makes stuff slow, and it can, but it doesn't always. But if you're writing a parser for something and there's like 11 million conditions that if it's not exactly right, if an index is out of bounds, if the string isn't as long as it's supposed to be, like this is mostly where you're like looking at an actual format, something that's a standard like HTML or DNS or HTTP, like or a programming language. There, I think it's a really good place to do a big blanket try catch where you call a parse function that expects everything to go perfectly, and then you put a try catch around the call to the parse function to say like, well, if it didn't go perfectly, then there was a parse error, and I'm going to handle it in this way. I definitely think that there's times when you should not consider all of the errors, but I think as a general rule, I think you should. I think you should be thinking about.
I'm not saying don't consider the error conditions. I'm just saying you should only consider the error conditions that you have sufficient knowledge or context to do something with. And if you don't, then that error is not your problem. But I think we need to keep moving on. Otherwise, we'll end up having a part 4, which is not necessarily the end of the world, but I don't know. So what would be the next bullet on the list?
Well, let's see. Well, we've got framework, testing framework, bundler. I think it took like another minute to let's talk about precision or something.
Look, all I can say about the number system is that you don't need to be an expert in it, I think. But again, it's such an intrinsic part of JavaScript. You should understand it. And if you're doing anything numerical with JavaScript, then you definitely need to understand it.
If you're doing anything with money, you need to know about precision and BigInts. If you're not dealing with money, if you're doing anything with floats, like a volume, volume is often measured in 0 to 1, like 1 being 100% and 0 being 0, or things like that are measured in percentage. You need to be aware of precision, because if you just add like, oh, I'm just going to add 10%, I'm just going to add 0.1 every time, your math is going to work out wrong, because you're going to think that adding 0.1 10 times is going to result in 1.0, and it doesn't. But I
think we can summarize it, I think, more or less as if you're just doing really basic forms, then you maybe don't need to know it. But if you're writing any actual code, then you'll probably run into it sooner or later. So you probably need to know it.
Yeah. The one thing that I'm going to push on that as my last thing, math is imaginary. It's not real. And so when you think like, oh, computers are so stupid, like, why is this work this way? It's like math is made up in the first place. There is no number 1 in the real world. There are no 2 birds outside. There are individual birds that are completely different and have a lot of similarities in that they're both birds, but there's no such thing as 2 birds or 2 stones. So anyway, like, it's no surprise that when we engineer computers, we have a hard time getting the math right, because math is just something we make up to approximate the real world. It's not a representation of the real world. So putting it in a real processor that exists in the real world is difficult, because then you have to have limitations and workarounds.
Anyway, we'll move to frameworks.
Yeah.
What do you think, guys? does a JavaScript developer these days, is knowledge of frameworks, or maybe even a framework, required knowledge for JavaScript developers these days? I think you're learning.
Absolutely.
Yeah, you're learning a new. Well, I think I read a tweet that you wrote that you're learning a framework. I think oh no, or yeah.
Oh no! Don't.
I feel like
don't publicly expose me, Dan.
No, but the question is, sorry, Amy. The question is, if you're learning it now, doesn't it mean that you didn't know frameworks before? And if you didn't, then how were you a JavaScript developer?
Oh, okay. So yeah, I mean, so what he's referring to is I am learning React because I'm in a position where I need to provide some mentorship in order to do better at my role, and I am not well adjusted, or I don't know enough about React to understand how it applies general programming concepts in its specific way. And so I am actually I bought 2 courses. I bought the Kent C. Dodds course, Epic React, which I think is fantastic so far. I'm not very far into it. I just got started with it, but he's obviously put a lot of time and care and concern into it. So I'll put that in the pick section, actually. And then one on Udemy, which is also really good. And the difference between the two is like $280, where the Udemy one is $10. But Kent does a good job. And if you want Kent, then it's worth the money, especially for professional. But anyway, that's aside the point. But so I know other frameworks, and I use things that are frameworky, but I find that I like to look at, I like to consider problems smaller. And the smaller the problem is, the less of a framework you need and the more custom you can be. I also like to work on novel things, things that are not cookie cutter type problems. But most problems out there are cookie cutter type problems, and most, many of the places where people are getting hired, they have large scale applications. And whether you build your own framework or you use one that exists, the concept of a framework is something that you will be dealing with. And I think it's good. We had here on the list, it's good to know at least one. I say it's good to know at least 2, because you want to be able to compare and contrast and understand when a paradigm is working and when a paradigm is just what the author of that framework was thinking of at the time.
Look, in an ideal world, JavaScript developers could get by without frameworks. I know that in many cases, frameworks are actually overused. There are many situations out there where the required functionality could have been delivered better, maybe even certainly faster and cheaper, with even better end user experience without a framework than with a framework. But the reality is, like you said, a lot of the problems that we face are cookie cutter problems, and frameworks are there to reduce the amount of effort that we need to invest in effectively solving the same problems over and over again. They do a lot of the heavy lifting for us. And the second thing is that, like the same way that the same thing that I said about TypeScript, but even more so. The reality is that today, without knowing a framework, you probably find it difficult to get a job as a JavaScript developer.
And well, you have to wonder too, like, what do you consider to be a framework? Because, like, for example, Express in Node, a lot of people call it a framework. I would not call it a framework. A framework would be something, to me, that the litmus test for a framework is how many of the letters M, V, and C does it use in defining what it is? Because it needs to be at least 2, and they have to be different.
Oh, so we got to the MVC now.
I don't know.
Well, just to clarify, MVC is Model View Controller, and it's a design pattern that's the variations of this design pattern are super common when implementing web applications. Effectively, you've got the model, which is effectively your database, your view, which is effectively your HTML and CSS,
or JSON,
or JSON. Well, JSON is part of, like you could say that it's part of the controller, really. Anyway, because it's what ferries the information from the model to the view. You don't actually the end user doesn't actually see JSON. But
unless it's a Node app, in which case your end user is another developer.
Yeah, well, in any event, you've got the controller, which is your business logic, which is the stuff that you write in JavaScript in order to, to get the information out of the model, do whatever required front transformations you need to do on it, and then hand it over to the view to be displayed, or get the user inputs from the view, and then again, do whatever transformations you need to do on them before storing this information back into the model. And most frameworks leverage the fact that this is such a recurring pattern and just make it easier to build applications that utilize this design pattern, or some variation of it. Now, in some cases, React for a long time like to say, oh, we are not a framework because we really just implement the view. And we don't really care about the model and only partially implement the controller. But the reality is that these days, more or less all the frameworks have grown to encompass all of this. So I think that effectively React is a framework now these days, and so is Vue, and so is Angular, and you probably do need to know one of them, or let's put it this way, you probably should know one of them, and knowing one of them, even if you end up deciding not to use it, and again, knowing one of them may be a prerequisite to actually being able to land a job.
Yeah, and I think it's good to learn one of the React style. If we're talking about front end, I think it's good to learn one of the React style frameworks and one of the Angular Vue style frameworks, because it's a completely different way about thinking about things. And I think what you'll find is if you tend towards being a backend person, I think you're going to like the Vue Angular style a little more. And if you tend towards being a CSS person, I think you're going to like the React style a little more.
I don't know. I need to think about it. Anyway.
Analogy.
Well, all the people that are on the back end that I know absolutely hate React. And people that aren't really interested in the back end seem to love React, or at least accept it unquestioningly.
Yeah, but these days, what is the back end versus the front end? I mean, if you're using React with something like Next, or Vue with something like Nuxt, you're doing both the front end and the back end in React or in Vue.
I guess I don't know much about that. I am still sticking to REST. Oh, by the way, earlier I was going to say the number one reason to learn TypeScript is GraphQL. It's like those two go hand in hand, it seems. And if you want to get the benefits of TypeScript, it seems like you'd want to get the benefits of GraphQL as well. Not saying that you should learn GraphQL. I think it's completely useless technology, but it's popular right now, and some people like it because it does magic on the front end, and some people like magic.
I think in next week's episode, we'll probably get to talk about it a little bit. But okay, so after frameworks come testing frameworks. What do you think?
I absolutely think this is important. However, again, I think it's extremely debatable. It's interesting to me that we have this as number 40 and TypeScript is 36, because I would most definitely flop them. But
well, this is what I would say. You need to go learn a testing framework in a language that was designed with testing in mind, because the JavaScript frameworks are insane. They don't make any sense when it comes to testing. Like, you had a bunch of people in the Ruby community come over, invade the JavaScript community, and rewrite the Ruby testing libraries in JavaScript. And then they're like, oh, well, this doesn't work at all. That's okay. We'll just introduce globals and introspection and rewrite the code on the fly. What the testing actually does is unrelated to how JavaScript works as a language. So I would say go to, again, like, Ruby is a great language to learn testing in. Golang is a great language to learn testing in. Rust is a great language to learn testing in. JavaScript, yes, you will need to learn testing for JavaScript, but because it's almost like learning a third language yet again. It's like, well, you got to learn JavaScript, and you got to learn TypeScript, and you got to learn JSX. And like, now you have to learn this testing thing that's yet another system of language that's shimmied into the JavaScript world.
Yeah. And when we talk about testing too, and I know, like, I don't know, maybe this is going to turn into a part 4, but it's not just a testing framework, when we say testing framework, like there's testing frameworks for the front end, testing frameworks for the back end, because there's like, do we mean unit testing? Do we mean end-to-end testing? Do we mean functional testing?
The browser automation.
Yeah, because like if you are a front-end developer, I think unit testing, I mean, unit testing to me is always going to be my favorite. However, I think you're going to get more bang for your buck, especially on the front end if you're doing integration testing. So,
well, yeah, unit testing is really hard with front end code because you can't just instantiate a mock browser within a couple of milliseconds.
Yep, Hello Cypress is really, really, really awesome. And then there's also failed to mention like component testing. So you've like React testing library, Enzyme. I really like those. If we want to talk about like, I kind of think of those as like, I don't know, this is not a technical definition, but there's sort of more like unit testing for the front end, sort of, depending on maybe not with React testing library because of it being like, I think it tests like the whole tree. But with Enzyme, you can do like a shallow, which would be more of like a unit test.
Without going into all the possible details and variations, I would simply state this, that if you're writing anything beyond super trivial code, beyond throwaway code, then you need to be writing tests. And in order to write tests in JavaScript, you probably are going to use a testing framework, because if you're not, you'll end up developing a testing framework.
Which might be better than the testing framework, just if you require some files and run them over a directory, being somewhat facetious, but also not entirely.
I think we have like another extra point, which is the bundler, but I think I can more or less summarize it by saying that in an ideal world, we wouldn't need bundlers. And if you listen to the episode with Yoav Weiss, then maybe we'll eventually get to the day where either you can say that we don't need a bundler, or alternatively, you might say that we'll have a standard bundle built into the platform itself. But the reality is that these days you need a bundler. Now, my take on it, though, is that, it's one of those things that you don't really need to know. You need to be able to use, which means that, whatever CLI you're using as part of your framework will probably generate the configuration for whatever is their bundler of choice, and you just need to be able to Google stuff and do some configuration. So unless you're really into DevOps, you need to be able to use them, because they're kind of mandatory for now, but it's not something like, deep knowledge. At least that's my opinion. Anybody disagrees?
I don't. And if we're good there, I am going to push us to picks.
I remember working my tail off to become a senior developer. I read every book I could get my hands on. I went to any conference I could and watched the videos about the things that I thought I needed to learn. And eventually, I got that senior developer job. And then I realized that the rest of my career looked just like where I was now. I mean, where was the rush I got from learning? What was I supposed to do to keep growing? And then I found it. I got the chance to mentor some developers. I started a podcast and helped many more developers. I did screencasts and helped even more developers. I kind of became a dev hero. And now I want to help you become one too. And if you're looking forward to something more than doing the same thing at a different job 3 years from now, then join the Dev Heroes Accelerator. I'll walk you through the process of building and growing a following and finding people that you can uniquely help as you build the next stage of your career. You can learn more at devheroesaccelerator.com.
Okay. I'm going to go first because I have a hard stop, and then I'm going to throw it over to the guys to finish. So my pick is going to be 10 powerful skills for the new decade. I love January, actually. I love the season, just like new beginning and, people like setting resolutions, pushing themselves. And I thought that this sounds like a very like self-help, maybe not worth your time, but I feel like there is actually a lot of good in this article. Like, for instance, he talks about learning to sequence things well. And like, this is one thing that I've always said is, like waking up early. A lot of successful people wake up really early. And like for me, I kind of developed that habit because I realized that if I go to the grocery store at 5:30 in the morning versus 11 o'clock on a Sunday, I'm going to get in and out within 20 minutes, whereas normally it would be an hour. So he just has like a lot of other like really practical things in here. He talks about spotting a convex versus concave world, which is really interesting. He gives like an analogy of lockdowns and things like that with just our current situation. So that will be my pick. I should throw it to somebody. Steve.
All righty then, since I added so much to this conversation today. So my pick is going to be a combination of movie and sports. It's a movie I came across and my daughter was watching this past weekend called Greater. And it's a true story about a guy named Brandon Burlsworth, who was an offensive lineman for the Arkansas Razorbacks college football team back in the late 1990s. He sort of considered one of the greatest walk-on in history because he walked onto the team. And by the end of his college career, he was an All-American and was drafted in the first round. Well, I don't remember which round. He was drafted by the Indianapolis Colts and was projected to be a starter on the offensive line as a rookie, and then was unfortunately killed in a car accident when he was driving home to his town in Arkansas. But it's really, really great movie. Not any real well-known actors except for the guy that plays his brother. But anyway, it's a real good movie, worth watching.
I'll jump in then. I think you're done, Steve?
Yes, I am.
I also have just the one pick today. I'm actually going to go technical. So it turns out that there was a virtual public event called Chromium University, where where several Chromium engineers gave lectures about various aspects of that project, and some of them like more general topics. And I've started going through the talks. There are something that on the YouTube channel, there are something like 50 something talks there, which range in time from 20 something minutes to about an hour. And they all look really interesting. I've not watched them all, but I've really hardly watched any, but they all look really, really interesting. So I'll definitely be watching at least some of them, and I'll put the link in the show notes. And that would be my pick for today. So AJ, you're the only one left.
All right. Well, so I said before, I'm going to pick both of these React courses. Again, I'm only like one module in on both of them, and I just kind of wanted to look at both to see, in part, what can I recommend to others. If you've got the $300 budget, if you're a professional developer, you've got an employer that you can say, hey, will you cover this, or you're serious about leveling up your React skills, I think I would recommend the Kent C. Dodds, kind of just from a matter of brand recognition. And, he's really influential. The style that he uses is styles, they're styles that catch on. The course is really well put together. He's got, does kind of his own, goofy personality stuff. Like there's Cody the koala that gives you hints in the comments, like he's a little koala emoji, and he does have a bit of a talking head, which I think for me makes it actually easier to focus. Like he's got the cutout of himself in like the green screen fashion. So it's just his like talking head that's in a portion where you can not like, it's not distracting from the code, but it gives you like a feeling of connection and like you have an instructor that's helping you. So, and then you don't have to do a lot of research because from the name, Kent C. Dodds he's a well-known name. So I think that, in that case, the $300 is worth it. $300 or, is out of your price range. The $10 React course that you want to get is the Steven Grinder course. And I say this because I looked at reviews on Reddit and some other places and tried to figure out like what, because there's 100 different courses out there. And part of the reason that you'd go with Kent C. Dodds is just so you don't have to do the research into which of the 100 is the best. Like, this is going to be good enough, whatever. But the Steven Grinder course, when you join, if you open up a new browser tab, you're always going to get the $10 discount on Udemy. Like every course is always $10 when you open up a new browser tab. If you just signed in 3 days ago, it's going to tell you the courses are $100 or whatever because you're in the remarketing loop and they want to reinforce the idea that, time is running out and all that. But Stephen Grinder is the one that seemed to have the best reviews. And what people said about him that I really liked is that he doesn't have a lot of fluff. He cuts it down to what you need to know. And his is a little bit more super beginner oriented. So he goes over some of like the install node type of stuff. Whereas Kinsey Dodds, I think he goes over that, but that course is definitely meant for, you're already a professional developer at some level. You've got at least 3 to 6 months job experience probably to take that. So those two courses, and then I'm going to pick again the Apple M1 Air. It's a Maze McGorkle. I mean, there's some problems with it. It's not like perfect, but I love it. Like I didn't expect that I would love it so much, but I do. And one of the things that sways me in a weird way is that I'm able to charge it with a 5-volt 1-amp phone charger. Like the original iPhone charger is, if I'm using it with that charger, it sips like 1% per hour or like 1.5% per hour. And if I'm not using it, then it's charging on a 5-volt 1-amp charger. And that's just amazing. And it's super snappy. There's still some bugs, like Big Sur is brand new. It's going to be another 3 to 6 months before they work the bugs out, and Big Sur is stable. So I wouldn't recommend upgrading to it. Stick with Catalina. But if you buy the new one and you might recognize a couple of quirks or whatever, but it's pretty cool. And I love the speed on it. I've switched to Safari as my primary browser so that I can get the benefits of the amazing battery life and all that. And I just open up Chrome when I need the dev console for something. And then my last pick is going to be the Zoom H1N, which is a recording microphone. It's just really versatile. You can use it as USB. You can plug other mics into it. It's kind of in the $100 range. You get a little cheaper on eBay. But if you need a recording mic for something, even if you're doing podcasting, I mean, it's not going to look as cool if you're doing like a visual podcast where it gets published to YouTube. It doesn't have that cool look that all the podcasters have with their stand-up, Yeti style mics and Shure style mics. But in terms of sound quality and versatility, it's just an amazing microphone. It has recording and all that, and limiting and auto limiting, and it's just super versatile. So if you need one, I'm selling off some of my other stuff just as part of spring cleaning. And I realized like I've replaced 2 or 3 microphones with just that. So I'm super happy about it. And that's that.
Without Amy, I think we should conclude the episode. So thank you all for joining in and listening to us ramble about the third and final, I think, list of things that JavaScript developers must know. And hopefully you found it useful. So thank you very much. Bye.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.
As one of the nation's most LGBTQ+ friendly places, New Jersey is a state of pride all the time. Discover where to stay, eat, play, and celebrate. From the soft sandy beaches of Asbury Park and Atlantic City to the urban scene in Jersey City, ivy-covered Princeton to happening Hoboken, laid-back Lambertville to funky downtown Montclair, and in between, everywhere. You are always welcome. Plan your trip at visitnj.org/LGBTQ.
Did you know if you pay your nanny or sitter more than $2,400 a year or $100 a week, you owe taxes? When Care.com HomePay does your nanny taxes and payroll, we make sure to find all the tax benefits you qualify for, up to $2,500 a year. From tax filing to payroll, Care.com HomePay has it all covered. When you sign up for Care.com HomePay, we handle your nanny payroll, W-2s, everything you need. Get your first month free at homepay.com with the code FREEMONTH2022.